Welcome, 13, day 4, chapter 13, day 4, and we're doing two-way tables today. So please start with warming up. Come back when you're ready to check your work. Remember with these, the question was the probability of selecting the second marble. So for the first one, selecting red first would be 4 and 6, right? And then selecting red again would be 3 left, because you're keeping the marbles out, so 3 and 5. And 3 and 5 is 60% or 0.6. So you're looking just at the second, what the probability is of the second one. So make sure that you zoomed in on the second probability alone. Okay. Now on the second warm-up, we're finding the probability of 2 red marbles. So read this over, pause this, check it out, come on back. So in this case, the probability of the first red would be 4 and 6, right? And the second would then be 3 and 5. So when you multiply those, you end up with 4/10 or 40%. So today we're going to construct and interpret two-way frequency tables of data when 2 categories are associated with each object being classified. Two-way frequency tables. So there are 3 types of frequency we're looking at. The first is joint relative frequency, second is marginal relative, and third is conditional. So make sure you understand the 3 types by the end of this lesson. So first, a two-way table is useful to organize data that is categorized into 2 groups, 2 variables. So if you have 20 children and adults, and you ask them, do they like broccoli? The table here shows you how you could arrange the data. So we have 20 total, right? And so when we add all of the values, all of the answers, yes or no, from the children, yes or no, from the adults, we get 20. And so the joint relative frequency would be to take the total and divide by the number of values. So let's take a look at this. Each number here will be divided by 20, right? So 3 out of 20 were children who said yes. 8 out of 20 were children who said no. So right here we just have the data. The next table will show you the joint relative frequencies. So here you go. The marginal, or the joint relative frequencies are right here. So we took each of these answers and divided by the number of people who were in this survey, right? 20. So here we have the joint relative frequencies. So they're just some important data that we can use to find marginal relative frequencies. They are found by adding the joint relative frequencies in each row and column. Okay, so when we add this row, we have 0.55. When we add this row, we have 0.45. Together, they total 1. Okay, so look at that. We had 11 children, and we have 9 adults. So that, I hope, makes sense that you would have a larger marginal frequency because you have more children, right? And in this case, when we add the yes and no for the adults, we have a smaller marginal frequency because there were fewer adults. Together, we have 100%. Okay, and marginal frequency also adds the yeses, right, and the nos. Look at how they're 50-50. So let's take a look back at the actual original data. 10 people said yes, 10 people said no. They were a combination of children and adults, but there were 10 in each of those groups. So you end up with 50% marginal relative frequency for yes and 50% for no. Together, it totals 100%. And the third type of relative frequency is conditional relative frequency. We find this when we divide the joint relative frequency by the marginal relative frequency. Conditional relative frequencies help us find conditional probabilities. Okay, so let's take a look at how this works. First, let's find joint and marginal relative frequencies. So here's a bunch of data. This table shows the results of randomly selecting car insurance quotes for 125 cars made by an insurance company in 1 week. They quoted insurance for 125 cars in 1 week. So First, we're going to make a table of marginal and relative frequencies using this data. Okay, so we take the information from the data table we just saw, and we divide each value by the total 125 quotes that were made, right? This will give us the joint relative frequencies. So if you have not done that, pause the video, find those joint relative frequencies, come back and check your work. Okay, so you should have divided each of those values by 125, giving you these joint relative frequencies. Whoops. And so now, to find the marginal relative frequencies, we simply add the rows and add the columns. So if you haven't done that, pause, come on back when you're ready to check your work. Okay, so of course, when we total the marginal frequencies, we get 100%. Okay, these are your marginal frequencies. Notice there were far more adults asking for insurance quotes, right? Almost 78% as compared to teens, which makes sense. All adults are seeking quotes, right? There are fewer teen drivers. They turn into adults, don't they? Together, their marginal frequency adds to 100%. Okay, let's try this again. We're going to create joint relative frequency, marginal, and then we'll talk about conditional relative frequency. So in this case, a reporter asked 150 voters if they plan to vote in favor of a new library and a new arena. The table shows the results. 150 voters. Would you like a library? Yes or no? Would you like an arena? Yes or no? So make a table of the joint and marginal relative frequencies. When you are ready, come back and check your work. Okay, there were 150 asked, so that's what you were dividing by in this case, right? And let's go take a look. It was 21 divided by 150 and 30 divided by 150 and so on, right? And so you ended up with these marginal frequencies, joint frequencies, and when you add them, you get your marginal frequencies. Okay, let's use this to answer a conditional statement. Okay, so we'll use the table to answer this question. If you are given that a voter plans to vote no to the new library, then what is the probability the voter also plans to vote no to the arena? Okay, so let's look at our table. Voting no to the library would be here, right? No library, right here, right? And voting no to the arena, both, here's our no-nos, right? Right here, no to the library, no to the arena is right here. So that would be 0.28 joint relative frequency, 0.28 out of the total, 0.48 who were voting no to the library, okay? And so that gives you the conditional probability of 0.58. It is the joint relative frequency, 0.28, over the marginal relative frequency of our no group, 0.48. What is the probability the voter plans to say no to the new arena after having said no to the new library? It would be 0.28 out of the total who are saying no. Notice that these said yes to the library, so they're part of this marginal total, right? The 0.28 out of the whole group that began by saying no to the library gives you your conditional probability, 0.58. So that is a quick lesson on joint, marginal, and conditional frequencies. And now try the lesson quiz. Come back and check your work when you're ready. Using that data, you were to create a joint and marginal relative frequency table. And so this is what you should have. Okay, and find the probability that a bottle was inspected in the afternoon, given that it failed the inspection. And so use conditional probabilities to determine which shift a bottle is most likely to pass inspection. Be sure you've tried it before you check. If it's not right, learn from it, right? You can do it. Pause the video when you're ready, come back. Okay, probability of passing if in the morning. Oh, if in the afternoon. What happened to my words here? It went to the back. Order, bring to the front. There it is. Okay, so this is the reasoning behind it, and hopefully you have some basic understanding. I know it can be tricky. You can do it, right? And there is your assignment. Have a good day.